This is Mission Control Houston. The orbiter Atlantis is just about to cross the coastline of northern Italy, having begun the 139th orbit of the mission. The flight control team is watching over the orbiter as it performs the what's called a Marcy football maneuver. The tracking map here in the flight control room plotting the orbiter's course as it proceeds through this elliptical maneuver in front of the shuttle Pallet satellite, which is located at the center of the crosshairs on the left of the screen. The orbiter is currently circling down just beneath the satellite and is currently at a distance from the satellite of about 45,000 feet or so. Crew Commander Don McMonigal notifying Mission Control that the solution that he's generating on board for the upcoming terminal initiation burn shows that burn will be an orbital maneuvering system engine burn, meaning it should be higher than about 8 feet per second total change in velocity. The clock's here in Mission Control counting down to that terminal initiation burn upcoming in about 43 minutes. Atlantis is just about to cross what's called the V-bar, which is the velocity bar, or velocity vector, which is the direction of travel of the spacecraft, thus putting it at its closest point to the shuttle Pallet satellite. This about 2/3 of the way through the Marcy football maneuver, the satellite is tracking the shuttle as it performs this elliptical maneuver, allowing the Marcy instrument, which stands for Middle Atmosphere High Resolution Spectrograph Investigation, to track the shuttle, gathering shuttle glow data as well as any presence of a trace chemical or gas trace called hydroxyl.
Atlantis Houston, check left flight controller power.
Okay, we copy. Thanks for the catch.
With the terminal initiation burn completed, a series of burns mid-course. The manual phase of the rendezvous, as the commander will transition to the aft flight station to fly Atlantis manually for the final stages of the rendezvous with the shuttle Pallet satellite.
Atlantis Houston, just a heads up that the ProxOps covariance matrix is on its way up.
Okay, we copy that.
Atlantis Houston, we see a good MC3 burn, and we'd like to confirm that SPAS is in the capture attitude.
And Houston, we initially had SPAS in sight when we had some of the residual daylight. We have lost sight of it at this moment, and we were too far out to tell what attitude it's in yet.
We copy, Don. We are confirming that SPAS is in the capture attitude.
Okay, we copy that. Thank you. sight now with the sunlight on it, and it looks like a diamond in the sky.
Well, we're glad to hear that, Don.
Monitoring the activities along with the flight control team here in Mission Control is astronaut Charlie Precourt, who will serve as the pilot on Atlantis' next voyage. He will be a member of that crew that does almost an identical rendezvous as the one today, only with the Russian space station Mir. Precourt sitting alongside Mark Garneau, who is the spacecraft communicator on this shift, is following along with the procedures and watching over the crew via the data screens here in Mission Control, as well as the rest of the flight control team. And we now see that the spacecraft has been captured at 5 minutes after the hour of 7 o'clock Central Time as Atlantis travels to the southeast of New Zealand on the 141st orbit of the mission. The current altitude of Atlantis is 162 nautical miles.
Houston, Atlantis, we have Krista Spas.
And Atlantis, Houston, we copy and we concur. That was a superb rendezvous and a great SPAS grapple. You've broken new ground with the R-bar approach, and your timing was perfect. You've given us some important data and a lot of confidence, and well done.
Well, Houston, thank you very much, and believe us, we are all very privileged to be part of this mission to planet Earth.
Okay, I'm sending the picture down.
Ellen, the picture looks great. You look great. Atlantis, this is Houston. Are you ready for the event?
Houston, Atlantis, I'm ready.
KNBC, this is Houston. Please call Atlantis for a voice check.
Atlantis, this is KNBC. How do you hear me?
I read you loud and clear, and I'm ready for questions.
Number two shot.
Good morning.
2 seconds to our window.
Good morning.
Ellen Ochoa, this is Diane Diaz and Conan Nolan in the KNBC studio, talking to you live this morning. Tell us, first of all, what it's like in space.
Well, it's really wonderful to be up here. I guess the two main things that you always think about and carry back home with you is a view of the Earth, and we've just had a lot of time to be able to look out the window while in amongst doing our payload activities. And, of course, the other thing is being in weightlessness or microgravity and being able to float around and move around from the flight deck down to the mid-deck really easily is a lot of fun, too.
Well, congratulations. You're speaking to us right after accomplishing quite a feat. We understand you've just been able to snag a 7,500-pound German satellite in a very unorthodox fashion. Tell us about that.
Well, we had the whole crew up here working to support that rendezvous, and it was very exciting, especially the view of the satellite as you come in towards it. And let me just show you a little model here to give you an idea of what the satellite looks like. This is the Krista Spa satellite that we were rendezvousing with today, although in reality it's all covered with white blankets, so we don't see all these different colors. The shuttle came to it from an attitude coming up from below, so the shuttle was between the Earth and the satellite, facing towards the satellite, moving in towards. And the rendezvous went very well, and it was so well positioned that it really wasn't a very hard job to go and take the robotic arm and capture it at the end.
Quite a feat, Ellen, and we're told also that this is something that's going to be instrumental in the future, in the next shuttle mission, when you actually try to go to the space station Mir. Is that correct?
Yeah, the type of approach that we were doing, where, as I mentioned, we were between the Earth and the satellite, moving towards the satellite, is an approach that they want to use when they're docking with the Mir station. That's because the orbital mechanics gives you natural braking, so you don't need to stop your motion toward the space station, and you don't risk pluming any of the parts of the Mir. And that's the main reason they're using it. And they're also looking to see if it uses less propellant. And it seems to me that we used very little today. We'll have to look at the numbers when we get back, but I think it looks very good.
Could you explain for us the importance of recapturing that satellite? What's inside that satellite that you weren't able to get back without actually physically removing it from orbit?
Well, the satellite has two main instruments on it. This big white cylinder in the center here is a cryostat holding the Krista spectrometers and telescopes. And then there's a smaller instrument to the side here called Marcy, which is a mil-atmosphere high-resolution spectrometer. And these were both atmospheric instruments. Krista was looking at dynamics in the stratosphere, really trying to find out more about weather in the upper atmosphere. We're pretty familiar with weather in the troposphere, but we don't have very much information about the kinds of winds or temperature changes or the movement of different air and chemicals in the upper atmosphere, and that's what Krista was looking at. Marcy was measuring two different molecular species, hydroxyl and nitric oxide. And those are both important in a lot of chemical reactions, one of those being ozone depletion, which, of course, is a major focus of our mission. And the satellite also has the data tapes on board that recorded all the data from these instruments, and that was why it was so important for us to capture it, to bring the data back, and also to bring the instruments home so they can be recalibrated once they get back on the ground.
Fascinating. Ellen, I'm going to switch gears a little bit and ask you a little bit about yourself. You're originally from California, and I think a lot of people in the viewing audience are going to be excited to know that you were born and raised in California, did your university work here as well, and now have accomplished this wonderful position of being a female astronaut, a Hispanic female astronaut, I might add. Tell us a little bit about your accomplishments and how this has come together for you.
Well, I was raised in San Diego, born in Los Angeles, and went to San Diego State University, and after getting a physics degree there, went to Stanford and did my graduate work in electrical engineering, and also worked in the Bay Area for several years at Sandia Labs in Livermore, and then also at NASA Ames Research Center. That was the first chance I had to apply some of the research work that I was doing in optical information processing to problems that NASA looks at, space missions, things like that. And after I'd been there a couple years is when I was selected as an astronaut and moved to Johnson Space Center. And I would like to say that it is especially fun to fly over places that you know and are very familiar with when you're on the shuttle. And although sometimes when we've gone over California, it's been quite cloudy, I have been able to see San Diego, Los Angeles, and San Francisco Bay, all with very little clouds, and hopefully got some good pictures of them.
That's wonderful. And tell us, was this a child?
Again, the red team has about 4.5 hours left to go in this 12-hour shift after having a busy morning retrieving the Krista Spas satellite. We're also now receiving television from Atlantis. This view showing an icicle as seen by a camera at the end of Atlantis' mechanical arm. Following the retrieval and berthing of the Krista Spas satellite this morning, the arm was removed from it and was positioned over into this viewing area where cameras at the end of the arm can see the icicle which formed yesterday during a supply water dump from Atlantis.
And also be advised, we have a good view from the elbow camera.
Copy. We see it.
This is Mission Control Houston. This television view is now live from Atlantis, from a camera mounted at the end of the mechanical arm and of the edge of the left-hand cargo bay door, looking very close up at the latches along the edge of that door.
Max is real happy with that view.
Yeah, it looks like the latches are clear of any kind of ice. Would you like me to zoom in any more or move the arm at all from here? Would you like me to continue to move the shoulder yaw to a smaller value to see what's behind the shadow?
Affirmative, Ellen. We commanded a gamma change, no response required.
I'm stopping there because we're sort of on the other side of the icicle now, and as I think you can see, the latches certainly look clean.
In this view from the television camera, the icicle and the supply water dump nozzle from which the water came a day ago can be seen on the left-hand side of the screen, just below the edge of the cargo bay door.
Atlantis crew and Ellen, just some words on where we think we may be headed with this RMS and this icicle when you're ready.
Go ahead, Dave.
We're putting our heads together with the engineering and ops teams down here and looking at using the RMS end effector to knock the icicle off. Our goal being to do it as close to the base, the attachment base on the door, that is reasonable without risking contact with the door. If you have ideas, or the rest of the crew, please let us know. We'll be thinking about this through the night and probably be back with a procedure in the morning.
Okay, Dave. Thanks for sharing that. We'll put our heads together and see if we can come up with some useful ideas as well, and we'll get back with you.
Okay, thank you, Don. Atlantis, Houston, we're ready.
Okay, we don't have any surefire solutions here, but we have been brainstorming, and we can pass along some information to you that might help in your process of coming up with a solution. One thing that we've thought about is whether we've exhausted the thermal option first, which might be suggestion of giving us some plus ZSI passes to try to put the sun on the icicle as much as we can before we try any other passes or any other options with the arm. Another consideration might be to, if we want to save the science, to partially close the port door, and while we're in the minus VLV attitude, to go to plus XVV so that door is pointed in a southerly direction so it gets the effect of the beta angle and the sun exposure. Along the direction of using the arm, what Ellen and I have thought about is, from our current position in the arm, rolling the wrist a little over 90 degrees in the right direction, that is the clockwise direction out the camera, and then so that the camera and the light are not between the end effector and the door, and then moving in the minus X direction to try to chip it off with the end effector. Stand by just a moment. And Ellen reminds me the reason we would need to do that is to avoid having the striker bar and the handhold on the end effector impact the door as we move aft slightly underneath the door. We can, from the WCS window, see the door, and it's questionable, but what we may be seeing from that window is the far edge of the ice that's most outboard and attached to the door. We might be able to see about a foot of that if what we're seeing is correct. And with our very best angle out the WCS window, we may be able to assist Ellen in being able to put the end effector close to the door, but not risk impacting it, and guide her through that by calling up proximity. One question we have about that option is whether or not the length of the arm from the wrist joint to the end of the end effector is long enough to be able to reach the ice. As we see it in the books, it's about 43 inches from the leading edge of the door back to where the wastewater dump nozzle would form the ice perpendicular to the nozzle. And we're not sure if the arm has 43 inches from the wrist joint to the end effector. Those are just some of the ideas that we're looking at, and we throw them in the hopper for your consideration.